Hello Year 10, it's Miss Bailey here. In this video we're going to be looking at calculating concentrations using moles. So last lesson we looked at how we could determine our concentration by doing our mass of a substance divided by the volume in which that substance had been dissolved. And we gave our units of grams for our mass and volume of decimeter cubed, which then gave our concentration units, grams per decimeter cubed. And then just a quick recap of our units that we use in chemistry. So the main unit that we use is this decimeter cubed one, because decimeter cubed is equivalent to a litre. And we looked at how we could convert between centimetre cubed to decimeter cubed and vice versa, as we said that a centimetre cubed is equivalent to a millilitre, whereas our decimeter cubed is equivalent to a litre, and so it's exactly the same conversion that we're familiar with, going from millilitres to litres. We are dividing by 1,000, and from litres to millilitres we are timesing by 1,000. This is a formula triangle which can be used to summarise the equation from last lesson, so looking at our concentration in grams per decimeter cubed. And the way in which we can use this is it helps us with rearranging the equation. So if we're looking for our concentration, then we would be looking to divide our mass by our volume. If we wanted, however, to get our volume, we would be dividing our mass by our concentration, whereas if we wanted our mass, we would be doing our concentration times our volume. But the way in which we define concentration generically is just the amount of solute present in a known volume of solution. So there is a different way we could look at how much of that substance has been dissolved, and that's by considering our amount in moles. So instead of doing our mass per volume, we can instead look at our moles per volume. So I'd just like you to pause that video whilst you turn this formula triangle into an ordinary equation, concentration equals, but this time in terms of moles instead of mass. So pause the video whilst you have a go at this. So we can also look at linking these two equations together, because there is an equation which links our moles and our mass. So we could substitute in, instead of moles, this mass divided by mR, and we can then rearrange it to make it look like this triangle here. And the simpler way of thinking about that is, in order to get our mass, we're doing our moles times our mR. So to get from our mole concentration to our mass concentration, we again just need times by mR. So if you can just pause the video whilst you note down that equation. And then we're going to have a go at some of these questions. So I will work through the first example with you. So with this question, we've been given sodium chloride, 15 grams of it dissolved in 3 decimeter cubed. Now we want it in moles per decimeter cube, so there's two ways of doing it. We could first convert our 15 grams to moles and then divide that by the volume, or we could work out our concentration in grams per decimeter cubed, and then thinking about that equation we just looked at on the previous slide, we would then divide by the mR to get our mole concentration. So I'm going to do the first method to begin with. So thinking about our mR of sodium chloride, we've got one sodium atom and one chlorine atom. So adding those two values together, we get our mR of 58.5, and our mass is 15 grams. So therefore we can use these to work out our amount in moles by doing 15 divided by 58.5, and that gives us 0.008 moles. And so our mole concentration is going to be 0.26 divided by 3, and that comes out to be 0.085 moles per decimeter cubed. So that was the first way we could do it. The second way we could do it is work out our concentration in grams per decimeter cubed. So 15 divided by 3, which gives us 5 grams per decimeter cubed, and then doing 5 divided by our MR of 58.5, and that comes out to give us the same answer of 0.085 moles per decimeter cubed. So pause the video now whilst you have a go at B, C, D and E. Just note with E, that dot there means that we've got 5 water molecules trapped with this CuSO4. So we can work out the MR of CuSO4, the MR of H2O. We then add the MR of CuSO4 to 5 lots of the MR of H2O. So pause the video whilst you have a go at these. So for question B, the answer is 0.028 moles per decimeter cubed. For question 3, the answer is 0.095 moles per decimeter cubed. For D, 0.23 moles per decimeter cubed. And for E, 0.4 moles per decimeter cubed. So you now have this worksheet to complete. So the first set of questions you will need to be converting from centimetres cubed to decimeters cubed, and then simply calculating our concentration like we've been practicing. For question 2, you need to be calculating the number of moles in those solutions. So you're going to need to rearrange that equation just like how we looked at it last lesson. So removing our volume onto the other side by doing the opposite operation. So volume is currently being divided, so we're going to need to times both sides by volume to rearrange that equation. For 3, we are using our conversion, which has been given on that worksheet as well, how we convert between our mass concentration and our mole concentration using our MR. And then question 4, we're being asked to calculate our concentration in both the mole form and the mass form, and similarly in question 5. So 2 ways in which you can do this, like how I showed you a few examples ago, is we can either calculate our mass concentration and then convert, or we could calculate the number of moles and calculate it that way. Either way, we have to calculate what the MR is, and it will give us the same result as I've demonstrated. So whichever of those 2 methods you want to do, we have to know how to do both methods, so it does not matter which method you choose for question 4 and 5. Thank you all for watching, and see you next time.